Hey you guys, I'm going to read the review book assignment for your days 7 and 8 assignment. Transformation of energy. Oh, while I do this, I'm going to be making some text annotations on the side and underlining important information. A transformation of energy is the changing of one type of energy into another type of energy. Some of these transformations are discussed in the following paragraphs. Heat production. Transformation of energy often occur when there is friction. For example, a glacier flows, some of its kinetic energy is transformed into heat energy at the interface of the glacier and its valley walls. This transformation occurs because of friction between the moving glacier and the rock of the valley walls. Transformation of energy also occurs when wind blows over the ocean, creating waves and surface ocean currents. At the interface of the atmosphere and hydrosphere, heat is formed. So I'm going to write, this was mostly about friction. Transformation of mechanical energy. All the energy of an object or system not related to the individual motions of atoms and molecules is mechanical energy. It can also be defined as the total of the potential and kinetic energy of an object or system. An object in motion has a kind of energy called kinetic energy. The faster something moves and the more mass it has, the greater its kinetic energy. Objects or systems can also have a kind of energy called potential energy, energy related to the position or phase. It may be thought of as stored energy. So I'm going to draw a line from kinetic energy and put in motion, and from potential energy and put stored. The higher an object is above the center of the earth, the greater its potential to fall, the greater its potential energy. The more mass that is involved, the more potential energy that is present. Either kinetic or potential energy can be transformed into the other. For example, water at the top of a waterfall has potential energy because of its position relative to Earth's center. As the water falls to a lower level, some of its potential energy is transformed into kinetic energy, resulting in an increase in speed. Transformation of electromagnetic wavelength. One example of a wavelength transformation is when electromagnetic energy is absorbed by an object and re-radiated at a longer wavelength. This occurs because energy moves from regions of greater to lower concentrations, and the region of greater concentration usually has a higher temperature and emits shorter wavelengths. So I'm going to underline that. Greater concentration usually has a higher temperature and emits shorter wavelengths. This type of transformation is very common at Earth's surface. There, the relatively short wavelength, ultraviolet and visible radiations from the sun are absorbed and re-radiated as longer wavelength infrared radiations. Since Earth's surface is much lower in temperature than the sun, it emits longer wavelengths than the sun's surface. Temperature and heat. The temperature of an object or region is directly related to the amount of heat or thermal energy in the object or region. Temperature. Temperature is a measure of the average kinetic energy of the particles of a body matter and is not a type of energy. Not a type of energy. According to the theory of matter, the particles of every material are in continuous random motion and therefore have kinetic energy. At any moment, some of the particles have more kinetic energy than others. The greater the average kinetic energy of the particles of matter, the higher the temperature. Your senses respond to temperature by sensations of hot and cold. However, to accurately measure temperature, you need to use a thermometer. A thermometer indicates temperature on a scale marked in degrees. 3 different temperature scales are in use in the United States. Relationships among the 3 temperature scales, Fahrenheit, Celsius, and Kelvin, are given in the Earth Science Reference Tables, Figure 5.5. Illustration that illustrates the method of converting among these 3 temperature scales. Heat and thermal energy. As explained earlier, thermal energy is the energy of motion of atoms and molecules. When the thermal energy of one object is greater, has a higher temperature than the other, some of the thermal energy will be transferred from the hotter body to the colder one. The type of energy that is transferred from hotter to colder objects is heat energy. It is measured in joules, a metric unit of energy or work. Specific heat. It takes 4.18 joules to raise the temperature of 1 gram of liquid water to 1 degree Celsius. It takes only about 0.84 joules, 1/5 as much, to raise the temperature of 1 gram of a typical rock and 1 degree Celsius. The quality of heat needed to raise the temperature of 1 gram of any substance 1 degree Celsius is called specific heat of that substance. In simpler terms, specific heat is the resistance of a material present to heating up or cooling off. Liquid water has the highest specific heat of naturally occurring substances, which is why large bodies of water have a major moderating effect on weather and climate. All other naturally occurring substances have a specific heat less than that of liquid water. Therefore, gaining or losing the same amount of heat causes equal masses of these other substances to heat up or cool off, respectively, faster than water. Review questions. How do the wavelengths of the electromagnetic energy absorbed by materials on Earth compare to the wavelengths radiated by materials on Earth? 1. The re-radiated wavelengths are shorter. 2. The re-radiated wavelengths are longer. 3. The absorbed and re-radiated wavelengths are the same. 26. The temperature of an object is determined by the 1. Average kinetic energy of its molecules. 2. Average potential energy of its molecules. 3. Total kinetic energy of the object. Or 4. Total potential energy of the object. Number 27. The temperature of a stovetop is 65 degrees Celsius. What is the equivalent Fahrenheit temperature? 126 degrees Fahrenheit, 132 degrees Fahrenheit, 144 degrees Fahrenheit, or 149 degrees Fahrenheit.